Hello students, let us start learning third unit of our curriculum, which is titled as Computing Similarity and Dissimilarity Among Data Objects. First unit, we learned about introduction to data mining, process blocks of data mining, and we learned a core task of data mining, which was data pre-processing. We learned all techniques of data pre-processing. Second unit was all about data warehousing. And third unit is all about finding similarity and dissimilarity among data objects. This is one of the core tasks in data mining process. A fundamental of data mining problem is to examine data for similar items. An example could be looking at collection of web pages and finding near duplicate pages. Other example includes finding customers who purchased similar products or similar items on the same day, maybe on the same purchase. First unit, while learning, we discussed Walmart's case study. And while discussing Walmart's case study, we could see that very untrivial relationship also could be found through such process. And throughout this lecture series for third unit, we shall be learning this interesting topic of what do you mean by similarity and dissimilarity, and what are the common measures which are used for computing similarity. Let's start learning. I told you what are the topics which we learned in earlier lecture. Basic data attributes which we learned, which was the most commonly coined term NOIR, which was nominal, ordinal, interval scaled and ratio scaled. We also discussed statistical description of data which is required for data pre-processing. In third unit of your curriculum, titled as Measuring Data Similarity and Dissimilarity, the core topics which we are supposed to learn is what is data similarity and dissimilarity, this which is termed also as proximity. What are the proximity measures for nominal attributes, binary attributes, interval scaled attributes? Similarly, what are the dissimilarity measures for numeric data? Its typical measures which are used, and we shall also learn about how to measure this similarity and dissimilarity for mixed types. And one of the commonly used similarity measure, cosine similarity, also we are going to learn in this particular video or in this particular unit. There are going to be 3 video lectures for this unit 3. In first unit, we shall learn about computing similarity and dissimilarity for nominal, categorical and binary attributes. In unit 2, we shall learn for computing similarity for numeric data attributes. Especially, we shall learn about Minsky, Euclidean and Manhattan distance. And in third unit, we shall learn about how to compute proximity for ordinal, ratio scale, mixed type of attribute, and we shall learn about cosine similarity. For today's lecture, we shall be learning about basic concepts of what is similarity, dissimilarity, what are the data structures which are used for data similarity. 2 of them, data matrix and distance matrix. Mainly data matrix is representation and distance matrix is matrix where we represent the distance between, which is nothing but a dissimilarity. And we shall be learning about how to compute dissimilarity for one of the non-numeric data type, which is nominal. Before we shall start learning about how to compute similarity and dissimilarity, I felt that we should have a quick revision of some terms which we have already learned, but we shall have just a revision of them. An attribute is a data field representing a characteristics or a feature of a data object. Noun, attribute, dimension, feature, variable are used interchangeably in the literature. And I realized that often students get confused with these terms, so I thought of having just a revision quickly. And term dimension is commonly used in data warehousing. In machine learning literature, we shall be using term feature, and while in statistics the term variable is used. So don't get confused with, they all represent attribute. So let's learn. Let's look at this table. Purposely I have shown one 2-dimensional table. We have learnt it in database management system, and we also are used to using such terminology, that tabular structure, for representing data. If you look at this table, we have object ID for object identifier, which is numeric 101 to so on up to 107, and there could be more records. First field is name, then gender, designation, salary, experience, age, height, weight, risk of BP, and risk of diabetes. If you look at this, you can recollect the terms which we learned in first unit, which was what is the type of these attributes. Object ID is numeric, name is nominal, gender is categorical, salary, experience, age, height, weight are numeric, risk of high BP is binary, risk of diabetic is ordinal, because we are giving terms like low, medium and high. This was just revision of what we learned earlier. Now let's revise these terms. We learned this was earlier was one of the data set, a sample data set. A data set has objects that are defined with attributes. So each row was representing object and each column was representing attribute. What is object? Object is one data record, that is one row which was one object, which was individual entity, which was defined use various features which we termed as attributes. An attribute is a data field which represents characteristics or feature of that particular data object. Noun, attribute, dimension, feature, variable are often used interchangeably. So for our reference, often while studying about distance and similarity, we use term dimension. This is why I have thought of revising them. So dimension refers in our case nothing but to the attribute. So if we have in earlier table, if we had, I don't remember, but if we had 7 features, then we call it as 7 dimension data. This is what is the difference in common life when we call as a dimension, and in data mining all features are our dimensions. So we say that number of features is equal to number of dimensions. And similarly with dimension, we also used a term dimensionality with respect to this data sets. So for our understanding, this is one dimension data. If we exclude ID and name, because they are object identifiers, and if we look at only height, and while plotting also I have used only height, and there one represents the ID and 163 is height. So height is given in centimeters. So all the points which are marked on the graph, let me choose a brush. If you look at this, this is representing identifier 2, that is Amit. We are not representing using a name with ID, so it is representing the second data object with height 170, and we are using only one dimension to define these objects. So ID and name, if we consider them as object identifiers, then what we are displaying on is only a height. Now if you look at the same data set, I'm here excluding a name. Now you can see that we have object IDs and we have height, and we can see it on this graph where randomly these points are placed. Now why I have placed them randomly is just to have introduce a term distance. If we talk about a distance with respect to height, then we can also say that distance between point 1 and 2, these 2 points, if we look at these 2 points, then the distance between these 2 points is 7. Similarly, distance between 1 and 3 is 2. And distance between any 2 points, similarly we can compute. And if we look at this points 1 with respect to 2 and 3, then we can also say that point 3 is closer to 1 as compared to point 2. We shall be using these terms. This is just an introduction to the term distance. We will see how to compute it. Now if you look at this table, now we are using 2 features. We are using height and we are using weight. So here we will say that as we are using 2 features, we'll call it as 2-dimensional data. Again, note that ID and name we are using as object identifiers. We are not using them as features. As only two features we are using, we call it as two-dimensional data. And then if we plot, we can plot it as this. Let's look at with a closer look. So on one axis, we are plotting height, and the other axis, that is x-axis, is height, and on y-axis is weight. And this is where we are using two features. We call it as two-dimensional data. Now question is, in earlier one-dimensional, we could say that number 0.3 is closer to 1 as compared to 0.2, because we were just measuring the distance with height, which was given in centimeters. Now how would we compute distance between any two points where we have two features? Or if we have three features, that is three-dimensional data. If we have four features, that is four-dimensional data. And here both these height and weight were numeric. What if one of them is ordinal? What if one of them is nominal? How do we compute distance between any two points? This revision was only to realize that the word distance we are using with respect to data points and with respect to x and y axis, which are nothing but for our features, and dimension refers to the word features. Also, to make it easy to understand that on this plot, if we look at in terms of dimensions for the features, then every data point is nothing but a data object. Data object on graph here is a data point. So wherever we talk about, wherever in literature you come across the word distance, we generally compute a distance between the data points, and here our data points are our data objects. And dimensions here refer to attributes or features. Let's learn how to compute this distance, which is nothing but a dissimilarity between any two objects. The term distance commonly is used for representing dissimilarity. Let us learn about all these terms. One more term which is very commonly used in literature of data mining is vector. We have heard about vector earlier. The word vector in physics refers to quantity with a direction. A term vector in mathematics is also referred as a term having quantity and direction. Now, how do it is related with data mining or a data science? A vector in data science is no different than vector in physics. Each object or a data point of a tabular data is sometimes referred as vector. Do note that we are using similar terminology in data mining. So each object or a data point which we just learned in a tabular data is sometimes referred as a vector, and it means in data science or in data mining a point in a space. Space was with respect to data set. A point in a space is nothing but an object of a data, that is we are referring to a vector now. So vector is a data point or object. Also a data point or an object is called as a vector because it resembles concept of direction and magnitude in physics or mathematics. Let's see how. Look at this diagram. We are using two features. One was, let's say, height, and one was, let's say, weight. Or could be this could be experience. Feature 1 could be experience of a person, and feature 2 could be salary in thousands. And if we plot data points, purple color are the points. An arrow, green arrow, is representing it as a vector. Vector formed by data points here has a direction pointing from origin towards data point. If you look at the arrow drawn, green arrow drawn, it is from origin to point. And magnitude of a vector here is considered as a distance from origin. In figure, you can note that these vectors are having origin from point towards from origin to data points. After revising these terms, let's start learning about these new terms: proximity, which refers to similarity and dissimilarity. Given that you can place your data in the space, you can measure how near one point is to the another point in the space. The concept of nearness or farness in the space is known as proximity. Proximity is quantified in two ways. One, by computing the distance, that is dissimilarity, or by computing similarity, that is nearness between any two vectors, which refers to nothing but two data points. Similarity is a numerical measure which measures how alike the two objects are, and obviously dissimilarity is going to measure how disliking the objects are. Let us learn how to do all this. Let us define these terms. Similarity is numerical measure of how alike the two objects are, and dissimilarity is a numerical measure how different two objects are. And proximity, do remember these simple terms. And proximity is the term which refers to either similarity or dissimilarity. So when we say proximity, it refers to both. When it refers to, we talk about similarity, it refers to computing a likeness. When we talk about dissimilarity, we are trying to find out how different they are. So dissimilarity and similarity both are important in data mining, which has three common applications: clustering, nearest neighbor classification, and outlier analysis. We can look at both similarity and dissimilarity. Now we need to assess how like or alike these objects are as compared to each other, to find out something like in a store we wish to search for a cluster of customer objects to be used for marketing, resulting in groups of customers with similar characteristics, like something like their income, the area in which they reside, or the age group of customers. Similarly, on blog also, with the help of tags, we are trying to find out what is the opinion, what is the reviews of customers about particular object. Now, in case of data similarity, when we talk about computing its similarity, we are actually trying to find out some numerical measure, or we say that a numerical measure of degree to which these two objects are alike, because these terms are relative. So similarities are higher for pair of objects that are very much alike, and this similarity is going to be lesser if they are not more similar. Similarities are non-negative. You have to remember few terms, that they are non-negative and they lie between 0 and 1. If value is lying between 0 to 1, we talk about its similarity, and when it is 0, we say that objects are not similar, they are totally totally dissimilar. And when this similarity measure comes out to be 1, we say that the objects are exactly similar to each other. So when we compute similarity between two objects, how do we compute? Because they are having multiple attributes associated with it. So when we compute data object similarity, we are going to actually compute similarity between their attributes. And we are going to talk in terms of similarity returning either 0 or 1, or the value lying between 0 to 1. Similar to similarity, when we talk about dissimilarity, it is a numerical measure of degree to which two objects are different. And it is also going to be a non-negative. It will lie between 0 to 1. When we get value 1, then they are totally different, because it is a dissimilarity is returning 1, means yes, they are dissimilar. And they return 0 means they are similar. Exactly opposite of what we use the term in similar. Similarity is also termed as nearness, and dissimilarity is very popularly used in literature with the term distance. Do remember that. Whenever we use the word distance, it means we are talking about dissimilarity. Now question is, how do you measure this proximity? Proximity refers to both, because data objects proximity is to be measured with multiple attributes associated with it. We might have a data set with 100 columns and 10,000 rows. Given a row, that is a vector or a data point or an object, how can we find the rows that look similar to each other, or finding a rows which are dissimilar to each other? The problem is also called as finding nearest neighbors of particular data point. We just represented objects as a data points. We just learned terms vectors, dimensions, attribute, data point, space and all. So we need, a problem is called as finding a nearest neighbor of a given data point in a space. Given a large data set of say 5,000 columns and 1 million rows, question is how can we group those rows, those that are having similar values, and such problem is also termed as clustering, which uses this proximity measures. Let us learn all about these measures. So proximity between any two objects, just we learned that is nothing but a function of proximity between corresponding attributes of those two data objects. If we have two data points, that is two data objects, say two employees, say Varsha and Hemant. If you want to find out what is proximity between these data objects, it is nothing but going to be a function of proximity between corresponding attributes of these two data objects. And these attributes are nothing but features. These attributes nothing but represent dimensions. So we just saw in one table that there were many features like weight, height, risk of BP, risk of diabetic, salary, age, experience and so on. So we are going to compute proximity of any two data objects with several attributes which are associated with it. How do we compute proximity between any two attributes? Is individually we are going to compute proximity considering each two attributes based on what is a type of attribute. So let us learn how proximity among objects is measured. Let us learn computation of proximity with respect to different attributes. So in other words, similarity computation is also termed as computing a strength of relationship between two objects. We just defined that what was clustering. We are trying to find out which are closer, which are similar rows, data objects, and we are going to group them in one group. So when we talk about similarity, we are actually trying to find out what is the strength of relationship between any two objects. When we termed that, in case of Walmart, we were trying to find out what are the two objects or three objects which are commonly co-purchased by a same customer. What is our objects when we when we buy a bread, what are the chances that we also buy a butter? What is the probability that we also buy jam? That is, we are trying to find out what is the relationship between any two objects. And similarity in data mining context is defined as distance with dimensions representing features of the objects. Small distance indicates high degree of similarity, whereas large distance indicates high degree of similarity, dissimilarity. Properties of similarity measures. These are very important and easy for you to understand. Well-known properties that similar objects possess. The first popularity is when similarity between any two objects is 1, it means that objects have maximum similarity, or in other words, we say that they are equal, nearly equal objects. Symmetric. When we say that any object A is similar to or exactly similar to B, it means B is also similar to A. We are going to compute the similarity with respect to attributes, and the attributes, if they are common for both the objects, then we say that similarity is symmetric. Similarity are usually non-negative, which are between 0 to 1, and also remember that similarity refers to nearness and dissimilarity refers to distance. Most of the data mining algorithms are related to similarity measure between objects, but similarity definition and its calculation are different for different data types. We will be using different measures for nominal. We will be using different measures for numeric data. We will be using different measures for binary attributes. For example, similarity measure of two numerical objects is often converted to dissimilarity and is later also referred as Euclidean distance. We will be learning how to compute Euclidean distance between any two objects. and they represent degree of diversity between any two objects. For nominal data, similarity between two objects is related to the number of similar values with the corresponding attributes. There are two commonly used data structures for similarity computation. One is data matrix and the other is similarity matrix. Suppose that we have n objects described with p attributes. These attributes are also referred as measurements or features. Such that object person, for example, the object person has attributes say age, height, weight and gender. The objects are represented, say x1 is equal to x11, x12, x1i, which is nothing but object x1 is represented with feature x11, x12 and so on. And object x2 is represented with features x21, x22, so on. This is like a matrix, like a representation which we are using. And these two data structures are data matrix and distance matrix. Let us look at this matrix, which is named as data matrix. This structure stores n data objects in the form of relational table, that is n by p matrix, where we have n objects and p attributes. So these are the attributes for the objects, and on row side we have all objects. In dissimilarity matrix, this is the structure that stores a collection of proximities that are available for all the pairs of n objects represented by n table. And here Dij is measure of either similarity or dissimilarity. Commonly used is dissimilarity or a difference between two objects, Di. This is why this is also termed as distance metric. And this distance dissimilarity metric has objects as a rows and objects as a columns, whereas in data matrix it was objects and attributes. Dissimilarity using data matrix is represented as in a matrix as shown in figure. Here Dij is equal to 0 for object with respect to itself. When we try to compute difference between an object and itself, it comes out to be 0. And also remember that D21 is going to be same as D12, symmetric property which we just learnt. And Dij is non-negative number, that is close to 0 when two objects I and j are highly similar or near to each other, and it becomes larger when they differ in high quantity. Dissimilarity matrix and data matrix. If we look at these both together, then on left hand side what we have is dissimilarity matrix, and on right hand side what we have is a data matrix. Dissimilarity matrix contains one kind of entity, dissimilarities, and so it is also called as one mode matrix. And data matrix is made up of two entities, that is rows and columns, objects at row and attributes at column, and data matrix is also called as a two-mode matrix. This is to place both of them on the same slide so that you can understand similarities and difference between both. Now, this were all discussion about similarity, dissimilarity, its definitions, data structures used. Now, how exactly do we measure and how do we represent similarity as a function? Measure of similarity can often be expressed as a function of measure of dissimilarity. That is, similarity and dissimilarity can be defined in terms of each other. And similarity is equal to 1 minus dissimilarity. Equation shows you that similarity between any two objects ij is nothing but 1 minus dissimilarity between objects I and j. According to data types of this attribute values, we have already defined or divided them into three groups. One was numeric, second was non-numeric, and third is mixed type. And for each one of them, measures of this proximity are different, and we have to learn all of them. Let us start with proximity computation for non-numeric data. The measurement and calculation of similarity. It plays a decisive role. So computation of this similarity has to be correct so that we get a correct results after data mining. This non-numeric data is further divided into three: nominal data, binary data, and ordinal data. And we shall be learning how proximity is measured for each one of them. Let us start with proximity computation for nominal attributes. Many times we cannot measure distance quantitatively. When we have something like we get a feedback, and feedback is something very good, good and poor. These are not quantitative terms. So it becomes very difficult to talk something like measuring distance quantitatively. But we can measure in terms of their categories. Numbers are used to represent this nominal or categorical data, and proximity can be measured. Say fruits, apple, orange and mango. We can give some number to them as 1, 2, 3, and then we can compute the proximity between these nominal attributes. Let's see how. Nominal attributes we have learned prior are nothing but names of things, some kind of symbols. Each value represents some kind of category or a code. For example, colors: red, yellow, green, pink, blue. Some designations like teacher, doctor, engineer and so on. Nominal attribute values do not have any meaningful order. Hope you remember we have learned that nominal attribute values do not have any meaningful order or a rank. They are not represented quantitatively. They are just names given to the things. Now, how do we measure proximity of nominal attributes? There are two popular methods used for measuring nominal attributes proximity. First method is simple matching in terms of M and P, where M is number of matches between the two objects and P is total number of variables or features which we are using. And second method is we use large number of binary attributes by creating a new binary attribute for each of M nominal states. Later we will see how we can represent binary attribute for each nominal states. First method is simple matching method. Dissimilarity between two objects I and j can be computed based on ratio of mismatches as P minus M divided by P. We just define that M is number of matches between any two objects and P is total number of attributes or features describing that particular object. So, to find out proximity between two objects which are defined with attributes, and if these attributes are nominal attributes, then we use this formula where we take a ratio of P minus M and P, where P is total number of nominal attributes and M is matches between these two attributes. While using this formula in reality, weights can be assigned to increase the effect of M, or to assign greater weights to the matches in attributes having large number of states. We will see this with some examples. For nominal data, similarity between two objects is related now. So here for nominal data, the similarity between two objects is related to number of same values, which are from their corresponding nominal attributes. Let us take one example. We have a binary attribute gender, male, female. Here for male we can represent it as 1 and female we can represent it as 0. Here binary attribute is special case of nominal attribute. We have an object identifier Alan, Anita and Anup as their names and gender as male, female and again male. If we look at these object IDs, that is which are names, and gender represented with 1, 0 and 1, that is male represented with 1 and female represented with 0. We can also now talk with terms of similarity and dissimilarity as similarity between Alan and Anita with respect to their gender is 0 because they both are different. One is male and another is female. And if we talk about their distance, then Alan and Anita value is going to be 1 because they are totally dissimilar. So it returns value 1. If they are similar, it returns value 0. So when we compute distance between Alan and Anup with respect to gender, it returns 0. And with respect to similarity for Alan and Anup, it returns 1. Let us look at this example. We have a sample data of table. Here test 1 is nominal. And we are going to compute this similarity matrix for this one feature which is test 1. Object identifiers are the employee IDs for 1, 2, 3, 4. They are testing some codes and code A is assigned to 1, code B is assigned to 2, code C is assigned to 3 and fourth employee is also testing code A. These code names is nominal data attribute. So we are going to compute dissimilarity matrix for it with the formula P minus M divided by P. So if you look at this distance matrix, 0, 0 is representing distance between any two objects. As they are similar, it is going to be 0. And we are going to compute the values distance between 2, 1, distance between 3, 1, distance 4, 1 and so on. Let us see how do we compute these values. So look at this table, object identifier and test. And we have to compute this matrix, which is a distance matrix. We have to compute these values with formula Dij, that is distance between any two objects I and j with respect to total number of features and number of matches. Here total number of features which we are using is 1. We are using just one feature, that is value of P is 1. And object 1, as we learned, is working on code A, employee 2 on B, employee 3 on C and employee 4 is working same as our employee 1 code A. Now how do we compute these values? So if you look at object 1 and 2, then number of matches are 0. So with our formula 1 minus 0 divided by 1 will result as 1. And similarly we will compute distance between 1 and 3 which comes out to be 1 because they are totally dissimilar. Distance between object 1 and 4 comes out to be 0 because we are using a formula where number of matches will be 1. With respect to code A, as both are working on code A, there is one match, so 1 minus 1 divided by 1 is going to be 0. And similarly we compute distance between every two objects and we get these values with our formula, and then resultant matrix is as this. For all diagonal values where it is distance between item, object and itself, it results into 0, and remaining values are filled in with 1, 1 with these computations, and only for the distance between 4 and 1 it results as 0. Similarity for this nominal data attributes. Earlier what we learned was distance matrix. Now if we try to compute the similarity matrix, exactly opposite of that. Similarity, we learned that relationship between similarity and dissimilarity. That similarity between two objects I and j is nothing but 1 minus its dissimilarity. So if we place the formula, we get as 1 minus distance between ij was p minus m by p. So if we substitute values, we get that similarity between any two objects I and j can be computed using number of matches divided by total number of features. And we can, instead of distance, we are now representing it using s. You must have noted that in distance matrix, when you take difference, that is distance between object and itself, it was 0. With respect to data point on the space with 1 dimension, 2 dimension which we saw, if you take a distance between any object and itself, it was 0. Now we are computing similarity. So if you compute similarity of object with itself, it results into 1. Let us compute for one example. The similar example which was testing a code. With now similarity formula, it is going to be number of matches divided by P. So if we compute, we get values as similarity between 2 and 1 results as 0. Similarity between 3 and 1 results 0. Similarity between 4 and 1 results as 1. So once we compute, the values come out to be this. The similarity between 4, 1 is 1, which is representing that the code on which they are working is similar. So object identity 1 and object 4 are similar, whereas object 1 and 2, object 1 and 3 are dissimilar. So proximity measure for nominal attributes, we learned how it can be done using simple matching formula. There is another way which is called as encoding scheme. Proximity between objects described by nominal attributes can also be computed with encoding scheme. What we do in encoding scheme is nominal attributes are encoded using symmetric binary attributes by creating new binary attribute for each of the m states. States could be something like good, very good and bad. It could be low, high, medium. It could be code A, code B, code C. These were nominal attribute states. For each state we are going to use some binary representation. For object with a given state value, the binary attribute representing that state is set to 1, while remaining binary attributes are set to 0. Now how? Let us learn with one example. For an object with given state value, binary attribute representing that state will be set to 1 and remaining attributes will be set to 0. For example, to encode nominal attribute map color, a binary attribute can be created for each of those 5 colors: red, yellow, green, pink and blue. We are going to create binary attribute for each of those 5 colors, which we call as 5 states of nominal attribute. For an object, say color yellow, the yellow attribute is set to 1 while remaining 4 attributes will be set to 0, and we shall be using this as proximity measure. We will see one example. Let's understand this encoding scheme with one example. Let fruits be a set which has 3 members, that is 3 states: apple, orange and pear. And we want to represent these with the binary numbers. And for representing them with binary numbers, 2 bits will be sufficient because 2 raised to 2 will be 4 and 3 is lesser than 4. So we will go for 2 bits. Now let's consider first member, that is apple. Apple is one of the first member in the ordering. So its first bit will be set to 1. And apple is one of the first 2 in the ordering. So its second bit will also be set to 1. So apple will be represented as 1, 1. Orange, if you consider, orange is not one of the first in the ordering. So its first bit will be set to 0. But if you look at orange among 2, then it is the first one in the remaining 2 ordering. So orange is one of the first 2 in ordering. So its second bit also will be set to 1. So orange is represented as 0, 1. Let's look at the third member, pear. Pear is not one of the first in the ordering, or its first bit will be set to 0, and pear is also not one of the first 2 in the ordering, so its second bit is also set to 0. So pear is represented as 0. Thus apple, orange and pear will be represented as 1, 1, 0, 1 and 0, 0 respectively. If we consider such 10 possible values for nominal attribute, then possible binary representation will be as this. So first member, as it will be first on the ordering, its all bits will be accordingly set to 1, 1, 1, and the last member generally is represented with this logic as all bits as 0. This is logical encoding, logical encoding with binary bits for nominal attributes. Further proximity of such attribute will be computed using simple matching coefficient technique, which is generally used for computing proximity in binary attributes. These proximity computation for binary attributes we shall be learning in next video. So this was enough for this particular video. If we summarize the points which we learned, similarity is numerical measure of how alike the two objects are. Dissimilarity is numerical measure of how different two objects are. And we learned similarity measure for nominal attribute in this video. And proximity is the common term which represents both similarity or dissimilarity, one of them. And nominal attributes proximity is computed with respect to its mismatches and matches, and it is measured as a ratio of p minus m divided by p, where p is total number of attributes and m is number of matches between the two attributes. These are few assignments which you have to submit after solving simple questions of defining terms: nearness, similarity, dissimilarity, distance, and proximity. How we compute dissimilarity of nominal attributes, you have to explain with examples. Two commonly used data structures, data matrix, and dissimilarity also you have to explain with examples. And given this particular table for roll numbers and their marks and grades, you have to compute the distance between them with respect to grades. And we shall learn in next topic, next video, how proximity is measured for the binary attributes, and binary attributes could be symmetric or asymmetric. We shall also learn how proximity is measured for ordinal attributes. Thank you.